And spear phishing from a tactic or technique is definitely very easily accomplished with limited preliminary intelligence collection. If you target any organization, it would be pretty easy to figure out how to get them to open up a document, go after like a press person and send them, hey, this is a press report about your company. Do you have a problem with this? They'll immediately open it without thinking. One of the other ways that you'll see this is through Trojanized focus of groups. So looking at, is there a group mailing account or some sort of position type person like a CEO, that might be someplace where we're seeing these spear phishing Trojanized attacks. I mention this because it's a good place to actually look for where you might find some of these zero-day type attacks, where you might find an unknown exploit occurring. Most targeted attacks focus on Trojanized access. It's hard to target this type of thing via SQL injection or something along those lines. So we do see a lot of targeted attacks focusing on file format vulnerabilities and that type of client-side issue. It is possible, though, to do website seeding. So if you know that you're targeting a certain group of people, you could very easily, compromise that website. I just saw one a couple of days ago where the New York Times had actually been, one of their pages was compromised. So people visiting that page, it was kind of a drive-by malware. So a targeted drive-by malware based on where people are looking is certainly another avenue of approach. So a couple of recent exploits that are ideal for this type of activity. In 2009, there's the Adobe Universal 3D array overflow. There was the Adobe JBig 2, which was pretty prevalent after last April when it came out. The Microsoft Excel CVE 2009. This one was very interesting. Also, it contained a couple of interesting approaches to how the exploit functioned. And just in case anybody didn't believe me about Adobe, this is just April of this current month. The amount of remotely exploitable Adobe exploits that came out. Most of them actually came out on the 14th, too. I'm trying to time this properly because sometimes I get a little bit nervous and speak really fast, and then I have 20 minutes at the end. So Toolbox. So there's no real automated products to speak of for exploit analysis, which makes it a little bit more fun. The primary tools that I'm going to use in this example are going to be a debugger, a hex viewer, the test environment, which in this case was entirely virtualized using VM Fusion, and me, or you if you're going to try this at home, which I recommend. Additional stuff to have on hand, previous exploits, so that you can kind of see how, if you know what an exploit was or you have some idea of what is being targeted, you can kind of reference that exploit code. Visual Studio, definitely useful to have on hand as long as any relevant SDKs. So if you're looking at something that has an SDK, or if there's some sort of, if you're going after a targeted attack against a certain SDK, that would certainly be useful. And then good intelligence feeds on vulnerabilities. So certainly things like CVE, the exploit DB, which has both RSS and Twitter feeds, very useful. Especially when you start seeing like an exploit come out, then you can kind of go back and look for it and look retroactively and see what you find. So a little bit about debuggers. There's OllyDebug, which is the open source user mode debugger, probably my favorite. Immunity Debug, which is pretty much OllyDebug completely written in Python, and it does allow for some scripting. So if you find that you're looking for a memory location or you want to search for a memory location, you could really easily do that from the command line in Immunity Debug. There's the Microsoft Debugger, which is more kernel mode, WinDebug, and GDB, which kind of put that as a joke. I don't think anybody's going to be reversing Adobe Reader with GDB. The hex viewers, there's lots of viewers out there. Honorable mentions to WinHex, OXED for Mac, Hex32, HT. But the coolest one that I found lately, File Insight by McAfee. Anybody using that? Oh, really? Okay. Super cool. It lets you auto decode. So if you have a PDF, for example, you can just grab the PDF, right-click, decode, go to inflate, and you'll see JavaScript or whatever was compressed using the flate method. It lets you grab exploit, and I'll show you in a couple of seconds, like the shellcode. You can actually grab that and run an XOR routine against it for XOR encoded shellcode, things of that nature. It does PE structure analysis. Definitely very cool tool and free, so highly recommend that. A couple of concerns about the test environment. So most cases, a virtualized test environment is going to be sufficient. It's easy to reload snapshots for one-time use exploits. So I've worked with a couple of Internet Explorer exploits that would only work one time, and then you'd have to reboot. So being able to just reload the snapshot certainly makes that useful. You can run as host only and keep restrict outbound communications so that if the exploit runs, you can not let it download a second stage and completely pwn yourself. And possible exploit errors from virtualized interrupts are something that you have to worry about here. Specifically with exploit code or malware that's looking for things like the interrupt descriptor table, trying to identify that. So you need to be aware that some code might actually be virtualized aware, and keep an eye out for that. All right, so those are the tools. And if anybody has any questions, feel free to just put your hand up and interrupt me. But those are the tools: debugger, hex editor, having some machines to test on, and just a lot of spare time on your hands, I guess. So finding a broken arrow. This is actually the most difficult part of this whole process, which is, or lucky, depending on how you look at it, being able to actually identify that somebody is using something that is 0-day or relatively new against you is a little bit more difficult to do. You're probably going to find it accidentally. One thing that I found is very useful here is user awareness. So if users are aware that they're being targeted and that people might be sending them bad things to do bad things to their computer, sometimes they'll just start forwarding you every bad thing that comes their way. You end up with a lot of spam that way, but every once in a while there's a nice little nugget. And then also creative IDS rules for catching things, and I'll talk about that in a second. If you have some creative IDS rules to actually find these 0 days based on, they might have found some really cool O-day, but they implemented some really weak shellcode. So if you have good IDS rules for shellcode, then you can potentially find something really neat. And then also things like HIPs, HIDs, and antivirus can sometimes catch this stuff based on heuristics, or if it sees some activity like download and execute, Symantec might catch something like that. Going through enterprise logs to find this stuff is sometimes worth the hunting expedition. You might get lucky. And then advanced network reconnaissance might identify that. So being able to write some tools to look for something that you might happen to know about through exploit feed or something like that could also potentially identify it. And I say that with some tools in mind because I know things like NetWitness and some of the other tools that I've played with, like you can actually write some interesting feeds to go out and look for that stuff. So like I was saying with IDS rule, just as a kind of example, you might create a rule to look for XOR DLL reference, like WS32. So if the exploit has to implement the WS32 library in order to com out, looking for 255 XORed values of WS32, it might be a lot of IDS rules, but potentially you could find, and you might find a lot of false positives as well, but you might find something that's useful. So as far as exploit structures, I'm not sure if people feel like they don't need me to go through this, let me know. But looking at like a generic buffer overflow. So if this is the buffer overflow package, part of it is going to be padding to just fill up the buffer. There'll likely be some sort of NOP sled to get the to execute the actual shellcode to slide right into that shellcode. And then there might be some padding depending on how the exploit works, or an SCH rewrite or something, and then the return address that gets it to actually to go into the code, into that shellcode, or into that NOP sled area. The area where you can maybe write some creative IDS rules is right there in the shellcode, and in this example, we have WQ bracket